Hello guys, in this video I would like to explain the applications of standardized normal table. You know that normal distribution is extremely important and plays significant role in the data analysis when you are dealing with the real life data. Maybe the data is not normally distributed, then you need to transform the data to approximately to see that the data has approximate normal distribution. This is no this is this needs to many videos tells what is normality and how we can achieve normality and so on. I will have some videos on this later. In today's videos specifically we will discuss about the applications of standardized normal table, and more specifically two application of standardized normal table. One is when the values of the z, the standardized normal variable, is given, and you need to find the probability or area, something like this. And the other is when the probability is given and you need to find some specific value of the standardized normal table. So the second is the inverse application of the first one. So we will talk about these two separately in separate videos. The first video is about when the values of the variable is given, the normal distribution is given, then you need to make it standardized, and then you need to calculate the probability. And the other video, I will not have this video now, but the link, I will mention the link in the description of this video, that why we need this unique standardized table. Okay, so let's see how we can use utilize the first application of standardized normal table. For this purpose, we need to have a problem in which we are asked to find some probabilities. So let's go to an example like this. This is the example. Let a certain type of storage battery last on average 3 years with a standard deviation of 0.5 years. So this is the average battery life on the average. I mean, this is of course average battery life. Maybe the data is for some years. So this is the three years is the average battery life, and the standard deviation is 0.5 year. Assuming that battery life is normally distributed. So this is the assumption that the battery life is normally distributed. So if you have a normal distributed random variable, then you can calculate standardized normal variable as well, which we call z or z. Find the probability that the given battery will last less than 2.3 years. So the question is, we need to calculate the probability that the battery will last less than 2.3 years. So you should make sure that the variable is normally distributed. So suppose x, we have x that is normally distributed. So the mean value of x is 3, and the standard deviation of that variable is 5, and this is the particular value of x, and we need to calculate the probability that the battery will last less than 3 years. So let's come to the solution now, and then we will explain that how we can utilize that application of the standardized normal table. I will explain the table as well, what is meant by the table. First, construct a diagram such as figure 6.14 like this. This has been constructed. Solving the given distribution of the area under the normal curve to the left up 2.3. So we need to find, because the question is the given battery will last less than 2.3 years. So we need to calculate this probability of x less than 2.3. So we need this area, and remember that this table, or you can say, I will show you the table. The table is constructed in a cumulative way. We need to evaluate the area under. Okay, this is accomplished by finding the area to the left of the corresponding z value. Hence we find that. Okay, so remember that you need to convert the variable first to standardized variable. This is important. I will do this with my graphic tablet, so I can do this now. let's suppose we can go to this. You should remember the mean as 3, the standard deviation is the, and the value is 2.3. So the first step in such type of calculation is you need to convert, first step, convert the variable x to standard normal z, and you know this is normal distributed, which is given in the problem, and this is standardized normal variable, remember. Second is okay, the first one, okay, let's do this. Z is equal to x minus okay, this should not be, we can remove this by using this option. Okay, now again, so this means variable, I remember I need to use little bigger. No, again, sorry. Okay, so this means x minus mu or x bar if it is population, then mu, if it is sample, then you need to use x bar. So let's see. Okay, so this means x minus x bar divided by s square, and if it is population, then you need to use x minus mu divided by sigma, and this is not square, by the way. Okay, so you can use depend on the data which you have. Z is equal to 2.3, that is the value of x, minus mean is 3.0 and divided by 0.5, that is standard deviation. So now you can see from the problem that this value is minus 1.4. Z value is equal to minus 1.4. So you have done the first step. Now you need to construct this figure. You can do like this, and this is very simple. You can do in here. You can plot better here. It's not very good, but you can draw a good diagram, and you can see the standard normal distribution. Remember, mean is 0, and this here is the negative values on this side and the positive values on this side. So we can say this can be like here. Z is equal to minus 1.4, and you need to find this area because they ask less than, so you need to find this area. Okay, so probability of x less than 2.3 is equal to probability of z less than minus 1.4, and yes, so we standardize this. You can do like this as well, here as well. Probability of x minus mu divided by sigma, and that's 2.3 is the value of random variable, minus mean is 3 divided by 0.5, because I just put it the values mu and sigma, which implies that probability, this is z now, less than minus 1.4. So now what you need to do, you just need to see in the table this value and just see the probability. Let's go back to the not let's go back. Now we can use the table. It's a standard normal table. Okay, now I need to explain what is mean by how this table is constructed. Just look at this z. The z value is given here, that start from minus 3.4, and how you read, and there are some values here as well, and these values are 0.00, 0.01, because the first value after decimal is here. So the second value is always zero. The first value is always 0 in this side, because that can be replaced by this, like this can be 3.40 and this can be 3.41, and the last value can be minus 3.49. Similarly, you can read this value, this column. This can be minus 2.40, and the last value, this value can be minus 2.49. So this probability, this the last one, this probability is for the value of the z, that is minus 2.49. So this probability correspond to the z value of minus 2.49. You need to read this and this as well. The 0, this is always 0 because there is a 4 here. So minus 2.49. Remember, you need to understand this. And similarly, you can go and you can read all these values. I don't need to explain this. And remember that this table is constructed in a cumulative way. Like minus 2.40. This means that the probability less than or equal to, that is accumulated like this, is accumulated like this. And you can see this is until here and until this one, the right tail, end of the right tail. So this is accumulated. Okay, now what we have the problem, we need to calculate this probability z less than minus 1.4. So now you understood the table now. So you just need to minus 1.40. That is minus 1.40. You can just look at the table and you can see minus 1.40 is this one. You can see this probability because minus 1.40, and remember the value, the probability is cumulated, it is summed until here. From this point to this point, this is the sum of the probability until this point. So you can have this probability that this area is less than equal to minus 1.4, and you can see from table very easily that this is the probability of the given probability. And now we can see in the example that how this solved. Yeah, the same probability is here. We did not check this probability in advance, but it is the same probability, remember. And by the way, this value is for x. Remember, x is given here. So when you plot z, then this value should be minus 1.4, like I drawn in this figure. Okay, so this is very simple. You can understand this very easily. Now we can move to another example, that how we can do if the problem is given in some other way. Let's look at this. Just look at this. An electric firm manufactures light bulbs that have a life before burnout that is normally distributed with a mean equal to 800 hours and a standard deviation of 40 hours. Find the probability that the bulb falls between 778 and 834 hours. Find the probability that the bulb falls between this and this. So there are two values now for x, that is a random variable which has I mean 800 hours for a bulb with a standard deviation of 40 hours, and then they ask that calculate the probability, find the probability that this bulb horse lies between 778 and 834. So this is a bit different problem, but using the same procedure. I will say I will solve this in, we can see this as well, but I will see this in a little different way. Okay, they ask about now problem 2. Okay, they ask that what will be or the probability that the bulb horse lies between two values. The values are The values are 778 and 834. 778 and 834. So we need to calculate this probability. Actually, they ask about this. So we start from here, from this statement. So we just start x minus mu divided by sigma, and you know this is general, the mean value of this random variable and the standard deviation. And you should know that what is the mean of this variable in this problem. 778 is the value of the random variable minus mean and standard deviation. Similarly here, this is the value of the random variable minus mean and divided by standard deviation. If you remember, I don't need to write the standard deviation, sorry. So I can just try this. Okay. Now I need the values. And you remember that the standard deviation is 40, by the way, I remember. What is the mean value? A mean values is 800, I think. Yes, this is 800 hours. If you see, you can see here 800 and standard deviation is 40. Just go back to the problem. So this is 800 and this is 800. Now you can write this implies that probability of you can have a single value from here and you can have a single value from here. And remember, this is now z. Remember, a variable minus mu divided by standard deviation. Z, you can have two values. So I just need to give more space to this side. Okay, now we can have two values. You can do this calculation. So simple. Minus 0.55 and 0.85. Minus 0.55 and 0.85. You can see this figure here constructed in this diagram. In this, this is area, for example, 6.8. So this is for this one. Remember that these are the values of the x. If you draw this for z, this should be minus 0.55 and this should be 0.85. So you need to find the area between these two. That's important now. Okay. We can do this. We can draw this. Okay, we can draw this on the side like here. And you can draw this as 0. Mean value is 0. And this value is minus 0.55 minus 0.55. And this value is 0.85. And you need this probability. So how you can calculate this probability? Remember that until this point, until here, I mean until the end, this probability is probability of z less than 0.85. So one way is to calculate this probability minus this probability, and this area probability is, I mean this is until here, it's not until here. So this probability is z less than minus 0.55. So calculate this probability until this point, and I already told you this is cumulative table. This is calculated by a cumulative way. So this probability, this area is using this formula, you can calculate the total area until here, and then you calculate this area. I mean this area and subtract from this one, you can calculate this. So let's see how we can do this. This means that probability of z minus 0.55 less than 0.85. This is equal to probability of z less than 0.85 minus probability of z less than minus 0.55. I hope you understood this. This calculate the whole area until here, and then you calculate this area until this point. Subtract this from this one, you will get the desired probability. Now you can use table two times, one for this, one for this. Just look at the table. I mean 0.85. Now you look. Okay, now you look the value of z, which is here. This is negative, so we can go to the other page. And minus 0.85. So it should be, this is not minus 0, this is 0. This is positive. So this is 0.8, and you need to go until 5. So this is 5. So this is the desired probability minus the minus, no, sorry, 0.85. So this probability is 8023. This probability is 0.823. I don't remember exactly. 8023. So there is 0 here. Minus, now you need to calculate this probability, that means this area. And this can conclude the whole area, this one, okay? So now you calculate this area minus 0.55 and subtract it. Minus 0.55. So this should be here. This is minus 5. And you should go here until, I mean, 0, 1, 2, 3, 4, 5. This is 0.2912. 0.2912. 0.2912. You need to subtract and you will get the desired probability. Just look and confirm from the example solved. Okay, so this is 8023 and 29. The same thing which I have calculate. I have just, start from the table 2912 and 8023, and you will get this probability. That is 0.5111. So this means that probability of x between two values is equal to 0.5111, and you can see the values are 778834, 77834. So you can interpret this probability now, because you can just look at the statement of the problem and then you interpret the probability. The question is, find the probability that a bulb hours between 778 and 834 hours. So you can say that the probability that a bulb hour lies between 778 and 834 as 0.5111, or you can say 51% of the bulbs have the bulb have hours between this and this. So you can interpret like this. So this is I think this is enough for this video, and the next video I will explain that how you can use this table in inverse way. Like you will be in today video we have the values of the random variable and we need to calculate the probabilities. In the next video we will have the probabilities, but we will need to find the value of the random variable x, z, not x, z, standardized normal variable. So this is enough for today, and I would like to record the next video after some time. Thank you very much, and see you in the next video. Ciao.